Hello friends, सबको नमस्ते. So today in this video we will make a pistol object reduction using a fast RCSN model on a custom data set. Okay, the data set which we have is a pistol data set. Let me show you. It's containing two folders, trade and test, and these are the images. Okay, and these are the annotations files. Let me explain you how the data is there. Okay. So it containing you can say five values. First value is a class name, class index you can say. Next two is your x center and y center, and this two is the width and height. This all values are in a normalized form. Okay, we have to unnormalize them so that we can use them easily. Okay, this way. Now this the test images with just images is there because we don't want any annotation file for the test. We just predict the bounding box around them using a model. So let me open this in a Google Colab. So before starting the explanation, let me show you how you can connect your data set which is present in your Google Drive to your Jupyter file. Okay, so this way when you will open and share dialog box, and even with the link, copy the link. Okay, done, and just go there and paste it here. Okay, remove unnecessary part from till slash here and from here till this one. Okay, this way, and copy this and paste it here. Okay, this way you will connect your data set with your Google Jupyter file. Okay, for connection we use gdown package. Let me run this cell, and this is the output file name. Let me run again it, and see this we will get the zip file here. To unzip that we use these three lines. See, it will first display the zip file. Let me see, this is zip file here. Now this is unzip. After unzip we will get this data set test and train containing two folder, images and labels, and test contains only the images for the testing purposes. These are the packages which we use for creating our models, or we can say train a model on a custom data set. Now this thing, you say that most of the time the annotation files have two problems, and before training we have to remove those annotation files which have problems. First problem is that there is a many chances, or we can say many times, annotation file is present, but particular image is not present for that annotation file. Okay, so so we have to delete, or we can say remove those annotation files whose image is not present in an images folder. Second thing, sometimes annotation file is present but this data is not there, empty annotation file is there, so we have to remove those annotation files also. Okay, before training, otherwise during training it will throw error, and sometimes we do not recognize what's the problem in annotations files and what's the problem in during training. So to avoid that we have to remove those files with two conditions. Now this are the labels and images directories. I make the list of that, and before training it will show me the word list directory, annotation directory. It will give me the length of before the pre-processing of the annotations files. Okay, now we will move zip annotation directories and image directory. It will give me at the first iteration it will give me this string, and second iteration it will give me this string. First we will fetch all the annotation file name from using this line, and now here we also we are getting all the annotation files name. Okay, and not annotation images file name. Why I had used set here? Because for the better performance of a greater speed. Otherwise if you do not use set here, no problem, it will definitely work. Now we have to iterate over the annotations because all the things happens with annotations only. From annotation only we upload the images, from annotation only we upload the bounding box data. So all things during training work around the annotations files. So we have to fetch annotations here. This way annotation give me the annotation file path. After that we have to remove, because annotation file contain last four you can say last four is the .txt. We do not want that. And the annotation file name is also the image file name, so we can work with that. So we have to remove this for text, or we can say character, and replace that for character with the jpg. This way we will get the image file name. After getting the image file name, we will find that image file name is na images, using here this images here. Okay, it will show me this particular annotation file is having images in an images folder or not. If it is there, no problem. If it is not there, we have to remove that. Okay, and continue, because continue is here, because if suppose annotation file is deleted, so with open.annotation file will throw an error, because we have removed that file. So why they need to open that file? It will throw an error that particular file is not present in that directory. After that, this is the first thing for condition where the annotation file is there but image is not there. We have removed that annotation file. Second thing, that particular image is particular annotation file is there, but annotation file is empty. At that condition also training will throw an error. So to remove those annotation files, empty annotation file, we will use this you can say this function, or we can say this lines. With open annotation file, we open the annotation file text file with reading mode as f. F basically contain all the file data, particular file data line by line. Here data line dot split. Let me print what thing happen here. Let me print line here first, and what we are doing, and print data. Okay, here break is there, one more break will come. Okay, let me run it now. See here line, here see here line basically this thing. It is not a list, so that we can it is just a text, or we can say just a string. Here we cannot fetch details directly easily. You can say easily we cannot fetch each and everything, class name here, this value is here, this value, this value. So to fetch the details easily, we use this line data line dot strip dot split. Basically give me the list of all the all the text present in that particular annotation file. Okay, this way we fetch the detail. After fetching the detail, we check the length. Sometimes annotation file is there, data is also there, but till here data is there only. This two things will not there. This thing also an error. Okay, because we want all the four bounding box values, otherwise during training it will throw an error. So to remove to know that, we remove this if the length of that data will be less than 5, because now the data is in a list format, we can easily get the length. If the length is less than 5, we can close that loss file and remove that annotation file. Now why this break is suppose, let me show you why I had used this break here. Let me make it comment and run it again. It will throw an error to me. If suppose suppose there is a file which contain more than 3 or 4 bounding boxes, or it's not throwing error. So let me show you what I'm doing here. Okay, let me open my notepad. Why I had used a break here after this for loop. See, suppose this line only have this thing. Okay, so it will work. For loop will learn first line here till here. We will get the length is 3. It means less than 5. It will close the file, means f close will be activated. F close get activated, and we have removed that annotation file. Okay, till here it's work normally, but here f contain all the data, means all the data till here, till all data. It means f contain more data. Now f contain more data, so f for loop will reach to this line, but it will not open that file, because we have removed that file and also closed that file. That's why we have used break here, because it read only one line. If one line is a read, we know that there is per length is enough for the training, and we have to break the for loop till here. Okay, now this for loop will removed. Now let me run it again. Okay, okay. This print will not become here. Let me run it again. Now it's okay. See, we have 917 landing, 917 before and 917 after. Means there is no annotation file with the empty annotation file, or the annotation file whose image is not there. Okay. Now this is a dataset class which we have created. It contains constructor here which required four we can say variables and image directories, annotation directories. Annotations basically contain all the annotation file name. Transform basically contain the pre-processing of the images if required, and this way we initialize the variables. Now this annotation give me the length of the annotation, how many number of images we have during training. Okay, now get item is the one important thing which is used by the data loader to load the data. Now idx basically you can we can catch that this is the id index value of the particular annotation file in the annotation direct in this annotation variable. First we will get the annotation file name. After that we will make a complete image path by using image directory annotation -4 till 4 we want, because last 4 text character we don't want, .txt, and convert that .txt with the jpg. Just this way we will get the image path. Now we will open that image path. If suppose image is not there, we will throw an error. Now if image convert image in a channel, because CB2 we are using CB2, and CB2 open the image in a BGR format, so we have to convert that in a RGB. Now we want in image dot shape here, height and width. Why I had used this height and width I will tell you before. Okay, I will tell you afterward. Okay, so don't worry. Now here we got the annotation file, because we have to open that annotation file and get all the bounding box details. Now boxes is a list and labels is a list which will append the bounding box and labels here. Now we will open the annotation file in read format. F line.f contain all the annotation file detail. Here data line.strip, I will tell you what is the meaning here. Class index give me first index value, means which particular annotations belong to which class. And here width, and we have only one class, so definitely 0 will be there. But Coco, we are using Coco dataset for faster RCNN, and faster RCN is fixed that for the background 0 index for the background, so we have to convert that 0 with the 1. Okay, we will convert them after we are appending that label, appending that class name into a label. Now I already told you that all these values x center, y center, box width and box height is all in a normalized form. We have to unnormalize them after multiplying it with the width and height. Okay, this way we have unnormalized them, and to fetch the detail x min, y min, and x min, y min. X min, y. So x min, y min is the top left corner of the bounding box. X max, y max is the bottom right corner of the bounding box. Now we have to get these values. How we can get these values using the x center, y center, and box width and a box height. It's very simple. So x min basically give me the top for getting the top left corner of left corner of the bounding box. We just have to move backward from the x center. So and how much pixel value we have to move backward? Just box width divided by 2. This way we will fetch the x min value, and for the y min we have to minus box height divided by 2, because for the y center, or we can say y coordinates, 0 index value 0 value start from the up of the image. Okay, so for that because of that we have to remove height divided by 2. This way we will get this x min y min value. For the x max, just add this, because we have to move forward towards the right of the corner of the bounding box. So we have to add box width divided by 2, and for y max just same, we have to move downwards towards the images. For that we have to add box height divided by 2. Okay, so this way we will get these 4 values. After getting these 4 values, we have to append them. And labels, I already told you that we, for the background, 0 index is for the cocoa data set weights which we use. 0 is index value is already fixed for the background. So and we have only one class, so that's why we have to class index plus 1, because already 0 is index already filled in or already there in an annotation file. And in annotation file, 0 value belong to the pistol class, but we have to replace that with the 1, and for that we have to add just 1. Okay, now here we have standard, and we are using PyTorch. That's why we have to convert this all in a tensor format. And if transformation means if any pre-processing is there, we have to apply that pre-processing. And after that we make a one dictionary target with keys, boxes and labels, and just return that. This way our whole class dataset is custom dataset, we can say, worked. And this and this help in with the data loader to load that data in a and we can use that in a dataset. Let me run it. It's work. Now I will explain you this whole thing. So number of classes we have is 2. What? How? We have one custom class, that is pistol, and one for the background. So we have 2 number of classes, and we are using fast RCN and ResNet 50 FPN model for object detection with ResNet 50 as a backbone. And the dataset which we use here is a, not dataset, the weights which we are using here is a Coco V1. Okay. Now let me run this, and then I will explain you these 2 lines in feature and model ROI box predictor. Okay. See what I want to explain you. Uh, Let me go down. See this box predictor, this box predictor, this, I think so, it's not there, this thing. Before replacing the box predictor, this thing is there. Oh, what's happening here? See this box predictor. This is a last layer which we can say which give us the classifications and the bounding box values. Okay, so here this box predictor here is containing in feature 2 and out feature 91, means 91 classes is there in Coco weights in which we use here, and 91 weights and 364. How it's come? Because when we multiply 91 with 4, and 4, why we are multiplying it with the 4? Because 4 is the bounding box values, coordinates x min, y min, x min, y min, x. So when you multiply with this 91 with the 4, you will get this 364. Means 2 layers will be act as a output layer. First is the classification layer, and second is the which will give us the bounding box values. Okay, so we we have to replace this box predictor till here. Till here we have to replace this. Till here we have to replace this with our with our own box predictor with our own number of classes which we have. Okay, how we can get? First thing, it's required in feature. We can change this thing. It's easy. But how? But we want in feature value. How we can get this in feature value? First we have to go to the model, then the ROI head, then the box predictor, then the class code, and from the class code in feature you will get this in feature value. Same thing happening here. Okay, same thing we are doing. See, same thing is doing here. See, model, ROI head, box predictor, class code, in feature. This way we will get the in feature value. Now we have to replace that box predictor with our own box predictor. ROI head, box predictor. This way we giving this from where it's tell that from which particular place we have to replace that. Torchman model detector we have using fast RC predictor and passing this in feature and class name. This way our model box predictor gets changed, replaced. Now here we model backbone parameters, means from backbone all the weights, we can say all the weights in a backbone, we have to update them. We have to make them trainable according to our custom data set. That's why we using param.required attribute true, means these weights will get updated during training. Let me run it. Now let me run this. How our model look like after changing, after replacement. See, number of classes we have 2. So that's why out feature 2, and 8. When you multiply by 2 with 4, you will get 8. Now we have to make the data loaders, or we can say the data loader which we use for the training part. Okay, so these are the directories. This way we fetch all the annotation file from the directories. After that we have to create the object of our class custom dataset, passing all the variable which is required during initialization or in a constructor, image directory, annotation directories, train annotation, which contain all the annotations, file name, transform. We want only one transformation or pre-processing. Just convert that particular image to a 2 tensor, means converting them into 2 tensor and changing that shape from HWC from CWH. Okay, this way we change the shape also. And using this data loader, we pass the train object batch size for shuffle with true, means shuffling will be there. Okay, and collaborate 5 lambda. This day we will get the train data loader. Let me run it. Let me print the length of the train data loader. How many we have? 230 batches, and each batch contains 4 images. Now torch.device coda, if torch.coda is available, else CPU, means we want to know that particular pre-processing computation performing on which device, CPU or a mod or CUDA, and we want that all the images and annotations all happen to be in on a same device. Okay, now this p dot required state. I already told you what is the meaning of this p dot required state. It tells us that particular parameter, or you can say where weights had to be updated during training if its value is true. So if p dot required value means if it is true, we have to make a list of that parameters, all the parameters, and after that we have to pass that parameters list into our optimizer, because optimizer basically updates the weights during training. And learning rate value will be 0.01, momentum will be 0.9, and the scheduler, which why we are using scheduler, because scheduler basically change the learning rate value, and sometimes it increase the accuracy and avoid the overfitting. Okay, and step size, what is use of step size means after every third epoch it will change the learning rate value after multiplying the learning rate value with the 0.01 value. See how it's worked. Suppose learning rate value initially is 0.01, second epoch, third epoch. After third epoch, it's changed the value after multiplying it with 0.01. Sorry, not 0.01, 0.1. And this act has a first, then second, then third, then after third epoch, it's changed again, multiplied with the 0.1. This way the learning rate value changes after every third epoch. Let me run it. Now we have to check the data loaders that particular the bounding box and the labels are correctly assigning to a particular correct object or not. We have to check that. Otherwise, if suppose we do not check that and just feed that data loader to our training, and sometimes there is a changes, or we can say there is particular bounding box that does not recognize the correct object, it will affect the training. So this way we plot the data loaders figure and represented the entire figure x this way till before using the label it is in 2D dimension. Plot the subplot 1 2 means here 1 row 2 column means we are plotting 2 images of size 10/6. X the variable we are converting that to 2D dimension to 1D dimension for the ease of iteration to over on a subplots. First we have to make a iterator of the trained data loader. After that we have to make a use of next. It will give us a 2 variable values, images and label. Images containing 4 values, 4 images, and target containing 4 images, annotations, data boxes, and a label. Okay, now we have 2 class name, pixels and a pixel and sorry, not pixel, pistol and a background. Now here permanent, why we have used permanent here, because data loader basically convert a band. We have used a transformer to tensor function. It convert the image shape from HWC to CHW, but this I am sure required HWC format. So to convert that format, we are using permute here, and .numpy basically convert that in a numpy format. Okay, target.idx basically give me the first image. If first iteration I will talk, it will give me the first image data boxes and a labels value. And this way because this way we fetch the details boxes dot targets and labels. Okay, this will fetch the details of the boxes and labels, how many annotation boxes there, how many labels there. Suppose there is more than one boxes, so we have to make a loop of that. This way we looping over that. We have to fetch all the x min y min value of the box of the on a first iteration, and this way we will get the height and width of the image x min y max. After subtracting that we will have to remake a rectangle patch using this patch dot rectangle, x min y min width and height, line width, h color red, and after making a patch we have to add that patch in a subplot. After that we have to make a text also. That text color will be red, and the class name label give me the label of that particular bounding box, and then this way we have to plot the subplot. See, it's working very good. Pistol, 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 pistol. It's working good. Okay. Now we will explain our training part. This we do not require any validation loss. We are not using. We are not we're not doing any processing on our validations, and this whole thing happening here. So let me explain you this. We have to epoch. We have 10 epochs only. Range num epochs. We have to print the message that the training is get started. Model should be in a training mode. Other because weights has to be updated. So model should be in a training mode. Train running loss. Give me the loss of all the batches, and we can use that for a entire epoch. Initial value will be 0. Now we have to iterate over the train data loader. It will give me two things: images and a label. Okay, where is my code? And same thing what the device variable which we have used before. Why we have used that? Because we want that pre all the computation and the processing has to be performed on a same device. So we have to make that images and all things has to be in a same device. This way we can do that images and then images to device. And targets, basically t dot target give me first image value. After getting that we have to make this cable item and v2 device, make them that all the things has to be in a same device. After that we have to just pass the images and target. It will give me this lost directory basically give me the list. It basically not a list, it is basically you can say the loss values of 4 type of loss value will be there. First is the classification loss, regression box loss, and FPN box regression loss. Because so not FPN, RPN, because fast RCNN use RPN, so it has its own regression loss, bounding box regression loss. Objectness basically check that particular bounding box contain object or not. This is a loss of that bounding regression loss, and we have to add all these box losses, and we make one loss of all 4 images. Okay, this way we get the losses of all the 4 wages, or we can say of one batch. After getting the one batch, we have to use this optimizer 0 grade, which convert a gradient value to a 0. Why we are converting the gradient value at each batch iteration? Because if we do not use that, the previous gradient value will be accumulated to a current batch gradient value, and it will affect the updation of the weights, and we do not want that. That's why at each batch iteration we want optimizer value should be have a 0 gradient. After that loss dot back, but basically here is a computation take place, because it basically computate how what will be the value of the weights after the updation. And here not here see loss dot back, but here the only the computation take passed, not the updation. Optimizer dot step basically update all the weights. Now we loss dot item give me the loss of all the 4 images of particular iteration of batch, and we will add that to our train learning loss. Okay, after that we are using a scheduler dot step, because scheduler dot step basically had to update a learning rate value at after every third epoch, so it has to be in a epoch for loop. After that we have to append that train loss in a train learning loss, and train learning loss multiplied by train data set. Here train data set give me the image, all the images present in that particular data set. Why we are multiplying it by the train data set? Because train running loss basically containing all images loss, not a particular batch loss, all images loss. That's why we are multiplying it the train learning loss. Let me run it. So here training take part. Let me explain this. Now we will save that model, use fast RCN custom PTH. Okay. Uh, I will explain you whole thing here, okay, so don't get confused. Let me make some changes here. Let me change this color values, okay, then come back because these values are very very not good much. So let me come back with the changes. Now let me explain you this plotation part. These are the packages which we use. Now one more thing I want to say, that all the pre-processing which you have performed before training on the images has to be performed after during prediction also, otherwise the model will throw an error. So first thing is a device. I will tell you what is the meaning of device here. The classes we have is two, the background and one a custom data set class we are just pistol. This way we make a model, then convert this in feature a model predictor. After that we have to load the weights of that particular model using this. Okay, now model should be in a evaluation mode, and after that model should be in evaluation mode. Now the model to device, ensure the model is on a correct device. Okay, now plot the subplot, figure out size. I already explained this to line. This transformation, the pre-processing which we have used is to tensor, because on during before the training we have to pre-process the image and convert that image into tensor. And this is a directory, list all the image annotation of the images file with present that directory. This is an extra line. Let me erase it. These are the class names, background and pistol. We have to plot 16 images, so we have to use this 16 here. First we have to get the image file name, random image file name. So for that, test directory, random Java choice of text list directory. Okay, then open the image, convert that, apply the pre-processing transformation, and squeeze 0, add a batch size. Now here batch size will look like this, 1 CHW. This way the shape of the image look like after you unsqueeze that. 0 means basically add one dimension or one dimension in it, because during training time be passing the batches in the to the model, not the entire image or not the one by one images. Okay, same thing has to perform here. Okay, with torch no grain means no updation is performed, and get the first image prediction. Model just pass the image in a tensor. 0 will give me the first image value, print that image. Now because I told you that when you this I'm show will require HWC format. To convert that CHW format into a HW format, we use permute 120. Okay, now prediction, now fetching all the values, boxes, labels and scores values from the prediction variable, or you can see a prediction dictionary. This will get all the details. Suppose there are multiple boxes, so we have to iterate over the boxes, and same way labels will be there, score will be there. Open that image. These are the colors values, and we have to zip that to, one by one, iterate over the bounding boxes, labels and scores, random choice of color. And we want to plot all the bounding boxes whose accuracy is, or we can say whose score is more than 80% or equal to 80% only. We do not want bounding boxes less than that. So this way we make a patch and add that patch to a subplot. I already explained you. This way we have to display the class. Okay, and plot.show. Let me show you how where the training this get for. Okay, so let me come back when the training gets over. So the training is over. The training loss is 0.0189. Let me save the model. Runtime disconnected. Okay, wait. Let me save it. Model save. Now let me run this cell. It will display the bounding box to the bounding box around the images, which is not used during training. So let me see how it's working. I think working is good. This is two means is there is something something we can change this, when we use this we can increase the score. It will work. Let me make it 9, then it will work very good. Okay, so it means our model is working good. So you can now download the model from here and use anywhere you want in a web application, mobile application, anywhere you want you can use it. and you can make a surveillance camera under a surveillance camera. Also, you can use this model. So this way our video come to an end. So please like, share, subscribe, and comment on my video. And this thing motivate me to make more videos like this. I will come back with more videos like this, more engaging videos like this, making more models like this object detection. I will come back with models on image segmentation also. So please like, share, and subscribe. Okay, please. Thanks to all.